Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. In this video, we will show one possibility on why the sun and moon wagon wheel across the sky. We will start by observing sunspot rotation from 41 degrees north latitude. I'd like you to pay attention to the time in the bottom right hand corner and the arrow that will be placed to show the alignment of the sunspots. It is around 10 o'clock, and you can see as we jump forward about an hour, each time the sun continues to rotate clockwise to our perspective. Here at 2 in the afternoon, it's moved almost 90 degrees already. And by its finish, it has. Next we will observe the moon doing the same thing. Again, the time in the bottom right hand corner, and we will observe this spot right here as it rotates clockwise. You can see each picture is about an hour later, if not more. The spot, just like the spots on the sun, rotate clockwise throughout the evening. I learned this myself from a great video content creator named Phuket Word here on YouTube. He has all kinds of videos on perspective and how your eyes work, so go check out his channel. All you will need to try this at home and recreate it is a ceiling fan, a flat circular disc, and your eyes. We will observe from 4 different vantage points: directly under the pole, halfway to the disc, directly under the disc, and then about the same distance outside of the disc. We will also observe it while it is rotating in a counterclockwise rotation. We will start out with our first video directly under the North Pole. I will zoom in after each rotation, focus, and place a little crosshair. As you can see, the blue is on top and the red is on the bottom. As I rotate it here, you will see that it really doesn't rotate to our perspective due to the fact that we are standing on the pole. Once again, the blue is on top, the red is on bottom. Pretty close to just how it was in our previous picture. This would be in a southerly spot from our vantage point. And again, we see the blue on top and the red on the bottom. Our next position will be taken from around 45 degrees north latitude, or halfway between the pole and the disc. You can see we're starting on the opposite side of the pole, to where we're always started with the blue on top and the red on the bottom. I would like to apologize for all the long pauses between shots, but I wanted to make sure it was a complete video with 0 cuts. Due to the fact that we have a different point of rotation, or perspective if you will, we will now notice a different amount of rotation when viewing the disc. As you can see, we have rotated a little bit counterclockwise. This happens in the early morning and the late evening. Here, around the midday point, we see that the disk is the same as when we started, with the blue near the top and the red near the bottom, just slightly askew. This next rotation is where we will see one of the greatest amounts of rotation. I would like you to pay attention, since we are always rotating clockwise while we are inside the arc of the disk, near the mid part of the day. And with our last rotation, we see that the disk has even rotated a little bit more clockwise. Here in our third shot, we will be looking directly under the equator. Again, we start from the polar opposite side, so the blue is on top and the red is on the bottom. We would never see this view in real life, as the sun would be in a position to where we would not be able to see it. This would be closer to sunrise, and we can already see the disk has rotated to the left. As we bring it up near the midday, it rotates even more to the left. Again, I apologize for the long videos. And here's where the interesting part takes place. Directly overhead, we have to switch and turn around to see it, which means we have switched 180 degrees to keep viewing the disk. And now the blue is on the opposite side. We have just witnessed a full 180 degree rotation because we ourselves had to turn to keep seeing the disk. This is just showing how a sunset may look while the disk is rotating constantly. This would be beyond our path to where we would be able to see the sun anymore, but as you can see, the disk does not stop rotating. Only from the center, or the pole, does the disk stop rotating. Then we move it out to around 45 degrees south latitude. Just like all the other shots, we start from across the pole, a position where we would not see the sun. We can see as it starts to rise that it is rotated to the left once again. Now, looking very much like it was at the equator, our blue is all the way to the left with our red facing to the right, as it rotated a full 90 degrees already to the left. Here's where it gets interesting, folks. When the disk is directly north of us, we now see it in the complete opposite. The red at the top and the blue at the bottom. The same way we see the moon in opposite directions, from the north to the south. We rotate it around again, and we see that the disk has rotated once again in a counterclockwise rotation. Now this brings up a very interesting question. Shouldn't the sun or moon from the southern pole do the exact same as it does from the north and not appear to rotate at all? Could one trip to Antarctica in one afternoon put the heliocentric model to bed forever? This is Good Times for All here, signing out. As always, thanks for watching.